Now let me introduce our final speaker for today, Dr. John Horack, the Senior Associate Dean of Engineering at The Ohio State University and the inaugural Neil Armstrong Chair in Aerospace Policy. He is also currently a tenured professor in both the Department of Mechanical and Aerospace Engineering and the John Glenn College of Public Affairs, the Interim Chair of the Center for Aviation Studies, and an advisor to the Buckeye Space Launch Initiative team, a two-time Spaceport America Cup winner. Thank you very much, Dr. Horack. Over to you.
General Bartman, thanks, and thanks to everybody for being here today. And I have some what I think is exciting information to share, and hopefully you'll share that as well. And that has to do with the role that the state of Ohio is playing in the key leadership role in the future of U.S. commercial spaceflight through something called StarLab, George Washington Carver Science Park. So next slide, please. So as you may know, today is the 41st anniversary of the first launch of the space shuttle, and the shuttle was instrumental in helping us build the infrastructure you see there, the International Space Station, which has had continuous human presence and American presence on board 24/7, 365 since November of 2000. So we're in our 22nd year of operation here, and NASA is now interested in moving beyond the infrastructure of a government-sponsored, government-run, and government-owned space station to the commercialization of low Earth orbit. Much as you have seen in the launch industry, a movement away from government-owned and government-designed and operated launch vehicles to commercial payloads and commercial launch, including a graduate of the Ohio University on board the International Space Station at this very moment through a commercial spaceflight mission. And the way they're moving through this is to have made 3 awards in December of 2021, 3 separate awards for commercial free-flying space stations in low Earth orbit. Those awards were made to Northrop Grumman, to Blue Origin, and to a company called Nanoracks. Each of these 3 have different designs and different capabilities. And the state of Ohio's role is significant in the Nanoracks Award, which is called StarLab, George Washington Carver Science Park. Next slide, please. So you can see here, this will sort of preview the words here, but Nanoracks was one of the 3 selectees, and it begun with a $160 million award by NASA to get started. And in this collaboration, there is significant Ohio leadership. So while I represent the Ohio State University in my day-to-day job, it's important to note that Zinn Technologies in Cleveland, Ohio is developing the customer research and lab hardware for inside the StarLab space station, the kinds of things that go inside in terms of racks and lab facilities and combustion experiments and fluid experiments, though that hardware will be developed in Cleveland. University Space Research Association, USRA, which is based out of NASA Glenn Research Center in Ohio, will manage the operation of the George Washington Carver Science Park on orbit. And the Ohio State University is responsible for developing and managing the academic research that will drive activities on StarLab, to develop ground-based analog laboratories, especially in ag bio, for control experiments and testing of hardware and procedures, STEM education and outreach activities in partnership with another company, DreamUp, which is a partnership here. The hardware is being built by Lockheed Martin in Littleton, Colorado. They're responsible for the engineering and design work. And then we're also assisted by the International Association of Science Parks and Areas of Innovation, which is actually based in Madrid, Spain. So I'm looking forward to perhaps my first trip over there to get to go meet them in person, which will be a fun trip. Next slide, please. So sort of the marketing org chart here, you can see across the top, Nanoracks, which is a space company that's been in business for more than 10 or 15 years now, flying commercial payloads on board the ISS, operating commercial research hardware on the ISS, operating a commercial airlock on the ISS. They're owned by Voyager Space Holdings Company. And you see the 5 main partners across the bottom, DreamUp for STEM activities, the Ohio State University, USRA, Zinn Technologies, and the International Association of Science Parks, and some of the roles there. The takeaway message is that Ohio is an essential leadership component of making this new and innovative science research activity in low Earth orbit a reality. Next slide, please. So we'll be operating in the context of something called the George Washington Carver Science Park. So you can think of, many of you probably have been to Research Triangle Park, or perhaps even Adlershof in Berlin, or the Cummings Research Park in Huntsville, Alabama. You're probably familiar with the science park concept where it's a community focused around research and technology or innovation and economic development. It just so happens that a key part of this science park will actually not be on terra firma, but in low Earth orbit, and that's the space station that you see there in the picture. So the idea is to build a research ecosystem. The nomenclature naming after George Washington Carver also probably gives you an idea that there's a significant amount of agriculture and biological research that will go on board. But the StarLab is the space-based component of that overall global research infrastructure, and in so doing, we'll hope to make the very first science park in space, with multiple copies of the space station being built and delivered later on in the future for a range of customers. So next slide, please. So you can see sort of the baseball card on the back, some of the research areas that will be areas of focus: agriculture, astrophysics, biotechnology, combustion, Earth observation, space plasma physics, space situational awareness across commercial, national security, and civil space research domains. The hardware itself, you see that a picture there, that inflatable, what I probably is more accurately called an expandable section, is about an 8-meter diameter square cylinder. So it's about 8 meters in diameter, 8 meters long. It's then coupled to a metallic section that you see there in the center, which has a slightly lower diameter, to create about a 25-meter long space station with 335 cubic meters of volume. It's intended to house a 4-person crew permanently, 60 kilowatts of solar power, and the goal is to have a single launch in 2027 with initial operational capability after that initial launch. Next slide, please. This is an inventory of some of the lab components that we see going on board initially. Some of it is a direct extension of some of the research capabilities that you see on the ISS. It's a little bit hard to read, but there's some express racks, cold storage facility, combustion, a lot of glove box research facilities for biology, fluids, and other things. But you see down in that red area that may or may not have copied correctly when I transferred from Mac to PDF, but plant growth, crop mutation, ag and bio is a big part of this. And that's one of the reasons that they came to the Ohio State University, is that we bring both a comprehensive, globally recognized College of Food, Agriculture, and Environmental Sciences, combined with medical research that goes on at the Wexner Medical Center, and a very, very strong engineering college, all placed in the context of a highly scaled and exceptionally well-recognized university research environment. So while I may talk a little bit more about ag and bio today than some other things, please know that I think, for example, the kinds of research that Dr. McNichols or Dr. Arnold talked about, these are also things that are highly relevant to space-based research. And so the sky is kind of literally not the limit in terms of what we're trying to make happen. Next slide, please. So from an economic development perspective and a research development perspective, you can see already through the collaborations in USRA and Ohio, we're looking at about a $200 million investment from Nanoracks that's being made in the state, supporting several hundred high technology jobs across engineering and research and hardware development and spaceflight operations. And one of the things that we're actually eager to pursue now is the attempt to locate the full up terrestrial analog facility, if you will, the physical twin of the orbiting spacecraft here in Ohio. So you can imagine a building perhaps situated next to an airport runway, where you open the hangar bay or the high bay door and you don't see 3 Gulfstream jets, but you see perhaps 2 full-scale high fidelity replicas of the operating space station, so that we can perform ground-based research, instrument procedure development, crew training, ground control training, and really build a high fidelity activity on the ground that mirrors what's going on in space, so that when you take that research to orbit, you have already sort of wrung out the kinks, and you have your ground control samples, and you've tested everything out in the most relevant environment you can find, with the exception of perhaps microgravity and the radiation environment that you see on board the ISS. So this is really, spaceflight research is really a pyramid, where at the pinnacle you have the research that goes on in space, but supported by an ever-broadening layer of ground-based, perhaps lower fidelity, but ground-based research that serves as sort of the rehearsal stage and the back office, and then the sort of testing laboratories where you actually develop experimentation that eventually makes its way to orbital spaceflight. So next slide, please. This is a busy chart. I call it my Ohio measles chart. Basically, it flows from left to right, and it was generated by Nanoracks that shows the research flow through the George Washington Carver Science Park, all the way from sort of order acquisition on the left side through the development of what's needed to get it to orbit. And then on the right-hand side, post-flight operations, data analysis, data sharing, commercialization, and then the important feedback loop that goes into how you might redesign experiments. And every place that there's a red dot, you see a leadership role for some entity in Ohio, whether that's the Ohio State University, University Space Research Association, or Zen Technologies. And you can see that Nanoracks is predicting about $600 million of research flow through this facility throughout its design life from about 2027 to 2035. So the opportunity to sort of attract a river to the vicinity of our community. You would never start a city perhaps and not put it near a river. This is an opportunity to put a river near our city and really grow the research environment across the state of Ohio, across multiple disciplines and domains. The one thing I'll point out on this complex flow chart is that sort of box 4 in the middle and box 5, where it says logistics, integration, and flight. Nobody gets to orbit unless they get through the mission planning and analog operations area. So this is one of the reasons that we're so interested in trying to attract and grow and build this full up terrestrial analog facility here in the state, so that not only here at Ohio State, but across the state of Ohio, research and technology development, both for commercial, national security, and civil space activities, have an anchor point here in Ohio. That's that last step before you go to space. So next slide, please. So this is an early opportunity, and I wish I could say I've got $100 million pot of money that you can propose to. I don't have a $10 million pot of money to which you can propose, but we're here to begin this partnership and work through and exploit these synergies across the university and private sector and federal government here to develop Ohio-focused research for StarLab. And we want to start now. 2027 may seem like a long time away. It's 5 years away. But by the time the spacecraft and the space station itself launches, we want to have a full and vibrant ground research program going on so that we're ready to step into the flight environment on day one. As soon as the solar panels are opened up and the hardware is activated and we power up and we start getting data, we can actually begin to do research. I also think this is a really important opportunity for the state of Ohio to grow our STEM education, our engagement of young people in science and technology research, using spaceflight as a platform for that, whether their interests happen to be in robotics or AI or instrumentation or Earth observation or water quality research or agriculture. Space is a platform through which we can ignite that energy and that excitement and leverage the opportunity for that, as well as for many stakeholders here in the state across DoD entities at Wright-Patterson, across NASA Glenn, and then our other federal stakeholders at NSF, NOAA, Environmental Protection Agency, USDA, and other government activities. I also think StarLab is an opportunity for us to grow our own entrepreneurship, technology, new companies, and innovation. We had a really great slide at the beginning that General Bartman presented about what OFRN has meant for job creation and starting new companies here in the state of Ohio. And I think StarLab and the George Washington Carver Science Park for us will be that in spades across multiple research domains. And so perhaps you can envision in the future, right next to the full up physical twin ground analog facility, we begin to grow, not only attract other research companies from around the country to have a presence in Ohio, but also significant presence from companies and activities that we grow ourselves in areas that might be for the intersection between ag and bio and spaceflight, or what does the microbiome of space habitats tell us that lead us to learn about the microbiome of other closed environments, whether that's submarines or hotels or restaurants or laboratory facilities. So we look to partner with OFRN in helping build Ohio as a global center for commercial spaceflight and low Earth orbit research that benefits existing stakeholders here in Ohio, our own research environment and ecosystem that exists here, as well as growing that for the future. So if you have questions, next slide, please. I will be happy to take any of those by email on the space side. Scott Shearer, who is the chair of the Food, Ag, and Biological Engineering Department here in the College of Food, Ag, and Environmental Science, as well as the College of Engineering, is also one of my technical experts, a partner here. So I think I'll stop there and we'll move into the Q&A if that's okay with you, General Barton. Thank you.
Absolutely. Thank you very much, Dr. Horack. That's fantastic.